Now we'll start implementing our own visitor classes. In the previous tutorial video, we mentioned that. So this is the hierarchy we are following. So these two classes, as we have seen, by adding labels to our input grammar file to Antler. So now all the methods correspond to all the variable type in the expression package, expression, variable, declaration, and etc. So now we want to add these two classes as the visitors. You can feel free to call any name you like, but I think for now, I want to make it very clear. These two pink visitor classes that we want to create over here really meant to really convert from the Antler parse tree node into expression type in our expression package. So let me mention that. So you can think about the Antler over here are the parse tree node. And over here, program is one of the expression in the model type. And let me just remind you very quickly, remember this particular diagram that we went through in the previous tutorial video, this way here, right? Program is just one of the class in the model package, in the expression package. And also another one is the expression abstract class, and with many possible runtime dynamic type. Okay, let me come back here. And the second class will be also Antler will be also again the parse tree node over here, and then expression will be in the model type in the expression package. One thing to note, as you will see, the way we declare these two classes will be as follows. Okay, when we, let's say for this case, for this particular class over here, we're gonna say extends, of course, expression base visitor class, expression base visitor class, but now we have to instantiate this to something, right? So now let me remind you here in the generated classes over here, if you look at, for example, expression base visitor. Okay, if you look at that, you can see every return type over here is simply just T. So now in this case, if I say extends expression base visitor and with, let's say, program. As soon as I say program over here, that means my visit program method is going to return a program. So I'm going to say visit program over here. Okay, as you can see, the visit program here. I'm just disregarding the parameter just for now. So what about another class that we're going to create? Another class that we're going to create is over here, AntlrToExpr over here. So now that class is going to extend the same class over here, but with a different instantiation of T. So now it's going to be extends over here, expression base visitor. But now our goal really is, if you look at that class again, we want to be able to visit declaration, visit multiplication, and etc. And the return type should be a model type expression. So now that's why we should instantiate it using expression. So now this will be expression. And then, so now, for example, the expression will be the type for visit declaration. Okay, hopefully you can see we are trying to extend the same class but with different generic parameter instantiation. Okay, so now that's what you're gonna see. So let's take a look at how we can create these two classes, and then we'll go ahead and implement them. The implementation itself has to rely on certain basics, certain specifics about how to use the parse tree. But I'm going to show you. That's why we want to have this tutorial to get you familiar. Now, under expression package, I'm going to create a first class. So right-click on the package expression and then say new class over here. And let's type it right. So AntlrToExpr. And then to really avoid, because now we are trying to use the base visitor from another package, so I'll rather type it in manually once it's finished. Okay, let's just finish generating it. So now I would say extends. I'll type it out here. Extends expression base visitors. Now I can control space in Eclipse is going to import it properly for you, for me. So the shortcut is control space. And now I want to instantiate T to be expression. And remember all the 6 methods I want to override, right? So now I will show you how you can generate this automatically in Eclipse. Very easy. So now I want to override, basically, if you go back to the base visitor here, if you look at the outline view, for this particular AntlrToExpr I only want to override these methods over here. These are the visit methods I will expect. Visit decoration, visit multiplication, visit addition, visit variable, visit number over here. So these are the visit method I will expect to return expression. And for now, for this particular class, I can disregard the visit program. On the other hand, when I create another visitor class, in which case t is instantiated into program, in that case, I only have to override the visit program class, program method. Okay, let's see how we can do that. So what I will do is I'm gonna go to the empty area for the class, and then right-click and go to source, and then you can see generates override implement methods, right? Okay, you can see override implement methods here, and then choose that. And now you can see from ExprBaseVisitor here, I want to choose everything except for the visit program. Okay, you can see visit variable, number, multiplication, decoration, and in addition. The only thing I didn't choose was visit program. And then I would say okay. Okay, everything is here. Okay, now I'm set to actually do some implementation. But before that, let me do something similar for another class over here, AntlrTo. So what I just did was AntlrToExpr. Let me also do AntlrToProg, in which case t should be instantiated into program. So now let me go back there, go back to Package Explorer, and then I will create a new class over here under the expression package and say new class. And now I want to call that AntlrToProg. Program. Okay, make sure I spell correctly. Okay, I did it. Okay, AntlrToProg, and then I say finish. Okay, and then I'm gonna spell out the extends clause. Extends, and now the same superclass, ExprBaseVisitor. Okay, so I'm just ExprBaseVisitor. Okay, I'll choose it from there. And now t should be instantiated into program, because the only method I want to use will be visit the program node, right? If you remember the previous diagram over here, the only method I want to use is the visit method for visiting a program internal node. Okay, I'll go back here, and now, of course, I can type it out, or I can just generate again. So right-click, and then go to source, and go to generates override implement methods over here. And then the only thing I would choose would be, in this case, visit program. And then I will say okay. Okay, that's the only method I want to implement. Okay, so now we have set up these two classes, and I would suggest we start from, let me close this guy here. I would suggest we start from visit all the visit methods related to expressions. So I'll start with this class first. So let's now start programming the visitor for expression. So this AntlrToExpr class. And let's start with the easiest one. I would suggest the way we go is from bottom up. Let's think about what might be the base cases for expression. In this case, it will be the number. Okay. Specifically, I want to show you the context where we use num, the token, in the grammar file. So again, let me go back to the grammar file that we did previously. You can see this is the context where I would say expression. One of the production can be expression produces num. So you can think about expression is the parent nodes, which produces the child node, which is num, some token for integer. So if I go back to the parse tree over here, do we have any instances of the expression produces num? We do. So now let's highlight it quickly. So now you can see this guy here, expression that produces 3 is exactly one instance of that. Okay, and then don't really mix with this particular one. So for the 5 over here, it belongs to a different production rule. Especially you can see the num over here, the parent should be the decoration node. And here the num, the parent should be expression node. Okay, notice that. Remember we did production before. Also we did a top-down parsing. So you will know which one is the parent, like expression, and which one should be the child, like a num. Okay, so let me go back here. So now what I want to do is to illustrate conceptually how we can do it, and as a review from the previous tutorial video, and then we'll go ahead and program it. Once we understand it conceptually, programming it in Java will be quite straightforward. If we want to, let's say currently if we are handling this particular node here, and remind you that what's the type of the nodes. Let me go back to Eclipse here. It's basically number context. Okay, so now I'm gonna write it down here quickly. So this is basically the type for this particular node over here is number context. Okay, that's simply just from the generated class by Antler. And then the way to do it is by saying this is the parent node that we are currently visiting. So the one we have is called visit number. And then we are visiting basically this particular expression node. Okay, I'll put expression here so we'll know this is the one I'm talking about. How can we do it? Basically, we just get the first child. Well, of course, this is the only child, but we still gotta go to retrieve the child node by position. And the position start with 0. So we should get the first child, which is 3 of this particular expression node. And then every leaf in the parse tree is stored as its string type, its string value. So now in this case, it would just be the string literal 3. So we should really convert that into integer, and we do have facility in Java library to do this. Okay, that's that's kind of the process of doing this. Retrieve the first child and then convert that into 3 being integer. Okay, let's go back here and then let's program that first, and then I'll annotate the diagram accordingly. So let me get rid of the default implementation. We don't need that anymore. So what I would do is, first of all, let's retrieve the first child. So what I can say is, you can say ctx, which is the parameter over here. So that ctx is referring to this particular expression node. Okay, so in principle, you will follow the same logic between the child and the parents. You should really refer to the best source to refer to will be the grammar file to see, for example, this is a child and this is the parents. Okay. Let me go back here and then let's now program that. So ctx dot, one of the method you can call on any context object will be get child. Okay, and then you're gonna pass an index. In this case, I'll simply say 0. Okay, and then now I want to actually get its text. Okay, and then because every leaves they are actually stored, every nodes in the tree, either external node or internal, you can all get their text. For all of them can get their text to actually print out or for comparison. So now in this case, I'll say get text. Okay, get text, and then I'm going to store that into maybe a string, the text for the number. So num text, for example. Okay, so now that's the first line. And once we get the num text, we cannot use this just yet to really create a new number object. You can see the return type is an expression, right? So what we want to do is, let me be integer here. Number is assigned to, we want to convert. So we can use the integer wrapper class dot parse int. And then we can give this num text over there. Okay, hopefully you can see. And then finally, we want to return an object of type expression. In this case, any of the subclasses of expression will be okay. And number is one of them. So I can say return and then new number and then num. Okay, hopefully you can see only 3 lines of code, but it really illustrates something very fundamental for the base cases. Okay, so now back to the diagram here. So in order to convert this green thing over here into the corresponding number objects, so get the first child, which is over here, and get it converted 3 into integer 3. So what I will have is, I'm gonna have this particular object over here, which is of type number. And then its value will be initialized to be 3. Okay, so that's basically the visit, what a visit number would do. And other visit method will be done in a very similar way. Apparently, you can see for the decoration, for example, let me use a different color. For the decoration here, you can see the number of children is more. This will be child at index 0. This will be child at index 1. This will be the child at index 2, index 3, and index 4. Okay, so how do we do for decoration? Okay, so I'll get back here in just a moment. Okay, so now we are done with the number here, and let's now do something. How about just visit variables? Okay, so if I want to visit a variable, I would simply just go for. Let me now introduce one thing before I try to visit a variable and visit declaration, because now thinking this way, when I try to visit a variable, how do I know if the variable really exists? Well, which means has it been declared already? So if you recall one of the example over there, let's say we talk about this over here. You can see this is a variable reference in line number 4, the right hand side of the multiplication. K is a variable over here, but now K is not declared previously. Previously we only declare I, and we even declare I for twice. So now we got two kinds of errors that they are not really grammatical errors. When you say grammatical errors, the sentence structure is not even right. But for these guys over here, something multiplied by something, and also the something is declared to be something. They're all grammatically correct. But now it's actually something deeper. It's so-called semantic errors. So now what we want to do is, while we are trying to parse, there are certain semantic error that we can handle right away. And then because as soon as we find out there's certain semantic error that actually should be reported, we can now say in line number 2 and in column 1, 2, 3, 4, in this case, in line number 2 and column 1, 2. Here, line number 2, column number 2, we actually try to duplicate, we try to declare a variable twice. Things like that. Okay, this one occurrence and this another occurrence here when K is not defined. How can we report such errors? Okay, the way to do it is to maintain certain auxiliary attributes of your visitor class and then try to accumulate it as you go, and then you can report errors by using that kind of data structure. How do we do that? Very easy. So now let me go back to Eclipse, and then I'm going to show you how you can do it in a simple way. Of course, you can once you understand the idea, you can definitely try other more sophisticated data structure if necessary. So now, first of all, I would say private, okay, list, and then using for the utility list of string. Let's say vars. So this will be to store all the variables that have been declared. Let me write the comments down. You may have some doubts about what are we gonna read the program? Are we gonna parse the program from end to the top, or from the top to the end? Because the order does matter when we want to figure out this kind of semantic errors. Okay, let me just write it down. Stores all the variables declared in the program so far. Okay, and now let me just write down something and then I'll illustrate to you on the tree. Okay, given that all visit methods are called in a top-down fashion. I will explain what the top-down really means over here. We can be sure that the order in which we declare variables into the list vars that we just declared is identical to how they are declared in the input program. For example, you see over here, if I look at this particular one, apparently I want to report this should be the one that's the error, because this is actually like a duplicate. So I should really count this as the first declaration for I, and this is already the second declaration for I. However, if I somehow parse my program from down into top, in this case, this will be considered as the first declaration, which is completely wrong, right? So now, how do I know this is really the case? Okay, that's something you want to understand about how we call the visit method. Think about how we're going to do eventually once we have implemented all the visit methods. Just the way we implement the visit methods will be bottom up, as I said. However, the way we execute the visit methods will be top down. Okay, so now I'll just say that verbally quickly. at the top level, we're going to say we're going to visit program on this particular node. Okay, and then we're going to visit its child from left to right, and then we're going to visit its left child first, and then followed by its second child, and then followed by its third child. So it's guaranteed when we visit the first child over here, we're going to see this particular declaration for I, the first one. And then we're going to see this particular declaration for J, and then followed by this particular multiplication. So the way, the order in which we visit each subtree corresponds to the sequential order of the input program. That's a very important remark that you should know. Okay, I'll write it down here for you. The way nodes are visited corresponds to the order of lines in the input program. Okay, it's a very important fact that you should really know about. Otherwise, we cannot declare the vars list to actually do the semantic errors checking. Okay, just something to note. It's really worth clarifying at this point. Okay, given that, we're going to go back to Eclipse over here, and once we got a vars, we're also going to accumulate certain errors. Basically, later on, we're going to report all the semantic error at one go. And there are only two categories of semantic error we're going to try to report for this particular tutorial. Number one, if the variable is declared more than once, we report. Number two, if we are trying to make a reference to a variable that has not been previously declared, we should report an error. Okay, so what I would do is I would say private list of also string. And then I can say semantic errors. Okay, I would say either it's because duplicate declaration. Okay, and also it might be that reference to undeclared variable. Okay, and notice that semantic errors are different from syntax error. If you got syntax error, that simply means the sentences in your essay are simply not grammatically correct. But when I say semantic error, it's more about the meaning of your program. If you, again, for this particular program over here, grammatically it is correct. However, semantically, you cannot use a variable that's not declared. Okay, so you really want to make that distinction very clearly. Okay, so now let's, given that we got these two things over here, so we can now start implementing the little bit more complicated visit methods. Let's say we go for, let's say visit declaration. How about that? Okay, that's something I did tell you a little bit about already. How do we visit this particular node? And again, I want to bring you to the context of the grammar. Okay, it's always worth doing when I refer to the source grammar, where the visitor classes are generated. So now over here, you see, if you see declaration, you got how many children do you have for the declaration? Declaration produces number 1, number 2, number 3, number 4, and number 5. 5 children. So indices will be from 0 to 4. Exactly what I just drew over here. So now in order to actually transform this particular node over here, I'm going to highlight it in blue. In order to visit this particular context node such that it's going to produce maybe a declaration for me. In this case, let's say that'll be the very first declaration here I want to create. How am I going to do that, right? Somehow I need to get a first child and get its text, which is I. I want to get the third child and get its text, which will be the type. I want to get a fifth child, the last one, which would be the number, okay, over here. And then I want to convert all these 3 into 1, 2, and 3 and put it there and then create a variable declaration object accordingly. That's what I want to do. Okay, let's see how we can do it. Let me go back to the Eclipse and then let's fill in visit declaration over here. Let me just get rid of the default implementation first of all, and then let's see how we can do it. Let's now get the ID first, you can see this is the this is ID. This is ID for the identifier. That will be just the first child, right? So I'll simply say string, and also ID will be CTX. So now you can see we're talking about declaration context. Okay, let me just write it down for you. You can see for this particular one, this one is simply declaration context. And you'll rather convert this particular declaration context objects into variable declaration objects. That'll be it'll be much easier to work with because it's completely under your control. Okay, let's go back here. So first of all, I would say ID will just be the context dot. Let's get the first child. Okay, there's something similar to what we just did for the number, and then get the text. Dot get text. Okay, that will be the ID, and then we want to say something like this. If this ID over here has been declared previously, we should really add this into one of the semantic errors. If it has not been declared, then we are fine. We can add it to the list of the declared variable. That's kind of the logic. Let's write it down quickly. If varts dot contains ID. Okay, in that case, I can say semantic errors dot add. Did I put semantic errors? Yeah, it's exactly over here. Oh, I just made a typo. That's why. Over here, of course, we should initialize these two attributes. I'll do that in a moment. Semantic errors dot add, and over here I can say error variable plus the ID plus already declared. But now I want to improve this particular error reporting message, because if I simply say variable I has been declared already, I wouldn't actually know where I make this mistake. It'll be very beneficial. I can locate exactly where this error was made. For example, in this case, that should be line number 2 and also column number 2, exactly over here. It'll be very beneficial if I can do that. Yes, there's a way. So what I will do is I will go back to Eclipse over here, and then I'm gonna do that. I'm gonna show you how you can do it. So we want to record for this particular context over here, what's the line and what's the line number and what's the colon number. Okay, in this case I can simply say token. Okay, let me say the ID token, and remember ID was the first child over here, right? And then let me write down something here and I'll explain to you what that really means. Okay, CTX, the context dot, and now I could have said just get child at position 0 because ID is over here. I want to say that one has an error. However, I can actually say the following. Okay, CTX dot, you will see one of the possible method I can call is called ID. Okay, I'll put it here. Okay, this ID again has some relation to the source grammar. I'll get back there in just a moment. And then once I get a particular token, I want to get the symbol. And the symbol is the actual token objects. Once I get the token objects, so basically go to the first child over here and then get the corresponding token. That's basically what we're doing. And then once we get a token, we can get its exact location. Okay, so now I can say integer, the line number to report will be, first of all, the token must be imported. So I can just move my mouse over and then import the one from AntlrV4. Okay, don't choose the first one, choose the second one. It should be V4. Okay, so now token is there, and then I'll say ID token dot get line. So that'll be the line for the particular token, and then I should get a colon as well. So now this one here, I can say colon here is ID token, and the method to use is called get character position in line over here. So this one tells you the position of that particular character. So for example, over here, you can see this is a character that we want to report, and what's its position in the line? Is position 0, position 1. However, 0 and 1 is not really intuitive when you actually see the error message. You don't usually count on 0 unless you're programming. So in this case, we may want to say whatever position it is, starting from 0 plus 1. Okay, hopefully you see why I'm doing this. Okay, so now I would say a position plus 1. Okay, so now we actually got basically ctx.id. So now let me just write something for you. Equivalent to, if I say ctx.get child 0.get symbol, they are equivalents. However, I'm just trying to show you a different way of writing things. Get child of 0, it's easy to understand, just go by position. But why could I say id over here? If I go back to the source grammar over here, you can see for decoration, what's the name over here? ID. So that means when in the case where you actually got unique names of the tokens that's being used in this particular right hand side of the production, you can simply say they will have a method there for you to call, simply call ID. Not surprisingly, there's a method called int type. There's also another method called num. You can use these names to refer to them. Okay, I just want to mention to you. Okay, so now if I go back there, okay, so now let me just so ID over here is a method generated to correspond to the token ID in the source grammar. Okay, as I just showed to you. Okay, and just convince you. And you can also see ctx dot. You can see there's also another one called int type, right? As I said. Also, there's another one called num. Okay, you can refer to either one of them. Of course, this mechanism may not work so well if you actually got two. If you got, for example, in your grammar, if you simply got over here, maybe you got num over here, maybe you also got num over here. So you got two nums. In that case, you'll be a little bit ambiguous. So the mechanism that will always work is by retrieving the child node by using position. That's what I would recommend. But I'm just showing you how if you can want to do it. Okay, so now we got a token here, and we got a line, we got column. So now we can improve this particular message over here. So now already declared, we're gonna see how everything work together in a later tutorial video. But now I just want to finish programming everything. And then we got a line over here, and then we say plus separated by a comma, and then plus the colon number, and starting from 1, of course, since we said plus 1. Okay, so now that'll be the case where if the variable already exists at this point, if the var, the ID that we are trying to add in already exists, so that means the variable has been declared. So we report it should be accumulated as an error. Who will actually use the semantic errors over here? I can tell you that later on in the application program we're going to build, we're going to use this particular attribute, but it's going to be later in the call chain. Otherwise, we can say vars dot add and then ID. Okay, so far this is only about reporting. Okay, so this is only about maintaining the vars list for semantic error reporting. Okay, and then we haven't really created objects yet, have we? So now we should really create this particular object, but it should be easy to do. All we're gonna do is we're gonna retrieve other children. So far we only got just the ID, just the first child. Why don't we retrieve other children? So what I will do is let's get a type. So the type over here should be child number 2, and also the value should be child number 4. Okay, when I say number, I mean the index. So I can say string. The type will just be int. In this case, ctx. Of course, in a more complex grammar, the type may not be just be int. It might be boolean, might be some even array type. ctx.get child, and then number 2.get text. Okay, so that'll be the type. What about the value? In that case, I can say integer, the value, and then convert it. Is a very standard way of doing converting string into integer. Integer dot parse int. And now in this case, what I could have said would be I can say get child 4, index 4. But now, as I said before, you can also refer to the token name over here. Okay, let me show you that as well. That will also work. Parse int, I'll say ctx dot num, and then dot get text. Okay, and now I have got everything I need. So now I got this value over here. I got, let me just be more precise over here. I got this value over here, I got this value over here, I also got this value over here. I can use all three values to initialize an object of type variable decoration and then return it for the visit method. Okay. Hopefully you're following so far. If you're following so far, you pretty much got a visitor idea for Antler. Okay, finally we can say return a new variable decoration objects and then with the ID over here and also the type and also the value. Okay, so the variable decoration is done. Okay, this might be the most complicated one to actually complete over here, but we just did it. Let me just maximize it. Maybe it's easier for you to read. So now let me go back to another one. What about we go to visit variable? For visit variable would be logically speaking, what should we do? If the variable you're think about what the visit variable might occur. Think about the input program here. This will be a reference to a variable like a k, and this will be another variable reference over here. So now when I try to should there be any error for this particular variable reference? Maybe not, because I was declared at least once over here. Of course, this would have been reported as an error already. And k over here should be reported as an error because k was not previously declared. So now let's use a different color to illustrate quickly. So now I want to do visit variable here, and it will be variable context. So now one of the example will be, let's say I, okay? And let me choose maybe pink over here. So now what I want to do is to visit this particular node over here. And it's going to be of type variable context. Okay, let me write it down. So this will be the variable context. Again, this is the class from the Antler. And think about this is the parents, and this is the child. Which child? The first child. So it should be child of index 0. Once I get it, I can now check to see whether the vars list, right? I'm also at the same time maintaining a list over here. And given that maybe I has already been declared, if I try to declare I again, of course, that should be considered as an error. Okay, so now let me just go back here and let's write put down the code. Again, I'm getting rid of the default implementation, and then I'll simply add in some more logic. Some part will be very similar. Okay, I'll just type it along the way. First of all, how do I get an ID? You can see the ID over here. This will be the child number 1. The first child, which will be child at index 0. I can alternatively also refer to it. You can see variable over here, exactly this ID, right? I can also use ID, the method, right? Again, you can use the method name being the token name if there's only a unique token that's in the context. So I can say token ID token. And then in this case, that would be the context, which is a variable context dot. I can either say get child 0 or I can say ID. I'll just say ID dot get symbol to actually get a token. Once I get a token, I can now calculate a line, right? And call it. Let me just copy from the previous one. They are just the same. You can consider factoring this out into maybe some auxiliary method just to avoid duplication. But for now, you understand the idea. And then I'll say ID over here. I'm going to get the actual node, the text. I'll say ctx dot. Okay, now I'm just using the other possibility. I can say get child over here 0, and then dot get text. And notice that this expression over here is equivalent to this expression over here, right? And now I want to say if the variable I'm trying to refer to does not exist in the vars list. If not the case, vars.contains over here the ID. In that case, I'm trying to make reference to some unknown variable. In that case, I need to add error to the semantic errors. Semantic errors add. Okay, let's write down the error quickly. Error variable plus the ID plus not declared. Okay, let's also put on the line and colon. Okay, so now I can also try to make use of what I had previously. Okay, and then I'll put it here. Okay, so now put a semicolon here. Okay, and finally, this is about the error reporting, of course, but now we also should return this particular object, right? So now, given the information about the I over here, we should also return the ID accordingly. In this case, it would just be the left-hand side of the expression. So that would be basically this particular variable over here, right? That's what we are doing. So now how do we do that? Basically, once we get I, just put it here. And then that would be simply just I in this case. So let me go back here, and then I'll say return new variable, and then the ID over here that we just retrieved from token. Okay, so that's a visit variable. And I think we got pretty much everything except two interesting cases. One is about how you visit addition. Another one will be how you visit multiplication. Once we know about one, the other one is basically just a clone with some minor change. And so now this will be the recursive case. Basically thinking this way. If I'm trying to visit, let's say, let me just give a different color here. Let's say I'm trying to do, let's say, this particular expression over here. Okay, this is one expression over here, and this is just another expression, right? We got two basically expression. An expression may be nested for as many levels as you like. That's why it's recursive. That's how we make the context-free context-free language infinite, right? Just infinite number of possibilities. So now in this case, let's say we talk about just the first one. Okay, let's say for this, the orange one over here. So now apparently you can see, let's think about the child index. Apparently this particular expression over here, let me make it a bit thicker. This particular expression is index 0, and this multiplication sign is index 1, and this particular expression is index 2. So we can retrieve basically the left subtree at index 0 and right subtree at index 2. And then each subtree might be arbitrarily complicated in general. So you can think about if this is the expression, if this is my, let's say, multiplication over here for expression, the left-hand side can be arbitrarily complicated, and the right-hand side can also be arbitrarily complicated. So now all I can do is to recursively call the visit method. Okay, so that's something I'm going to show you. And then and then we can create a concrete objects of addition or multiplication accordingly. For example, over here, so I'm going to do for this particular one. So this now is going to basically create this particular multiplication object over here. So that's to say recursively visit the left subtree. That should give you some expression, in this case a variable, right? Just a j. And also recursively visit the right subtree over here. In that case, it will just be a number. And then I try to link the left to the left visit result and link the right to the right visit result. And then it's pretty much similar to how you construct your visitor program previously in the software design course, just the same. So now we're just reaffirming what you learned previously. Okay, let's just do the visit multiplication. So we should retrieve the first and third child, being the left and right, and the second child is the operator, in which case we don't need to check the operator because now we're already in the visit multiplication. It's guaranteed. The context tells us it must be that. Okay, let me just be more precise over here. Okay, so now I want to write it down for you. So you can see for this particular expression over here, okay, for this particular expression, it would be the multiplication context. Multiplication context. And this one simply match the multiplication context. On the other hand, the addition context will be something like this particular one. Okay, you can see the expression over here. This one is of a different context. So this will be addition context. It's guaranteed when you are talking about this particular context, it must be of this particular structure, left and right. And how do we know? It's according to the grammar. So now if you see the grammar, you can see for multiplication and addition, it's guaranteed to have a left I also have a write. The child at index 0 and another child of index 2 is guaranteed. You don't need to worry about how exactly it is implemented. You just have to know how to use it. Okay, so now how can we retrieve and then visit recursively? So let me just see the multiplication. Let me write down something hopefully you can understand. Okay, so now expression, okay, that's the type I want to create. So expression from the expression package. And then left child should be, if I simply say ctx.get child over here at index 0. If I simply do this, it's not going to compile because it would say you cannot convert from parse tree into expression. So that's very interesting. That's why we need this kind of conversion. You can think about, in this particular case, for multiplication. This particular node that we are talking about is of type parse tree. What we really want to convert that into is an object like this of type multiplication. At the moment, we just cannot assign this guy here to this guy here directly. We need to do some conversion. So what we do is you simply recursively call the visit. And this visit method is simply inherits from, remember this class inherits from ExprBaseVisitor, and the ExprBaseVisitor also inherits from other class in the Antler library. We can just call that. You don't need to know how to implement that. So I will simply say over here. Oh, I said I'm gonna do multiplication first, right? Okay, let's do that first. Otherwise, my previous illustration wouldn't make sense, right? I really meant to talk about multiplication in the previous one. Okay, so now get the first child, and then I want to recursively visit the left subtree, basically. Okay, and think about recursively visit the left subtree of the current multiplication node. Okay, and then return, of course, the expression. The visit method always return an expression. Okay, so now we do something very similar. What about the right hand side? Okay, expression right is visit ctx.get child, and don't miscount, right? It's not 1 because index 1 is this particular multiplication sign, so it should be index 2. Be careful. Index 2 over here. And then, so now once we got expression on the left, expression on the right, and we know we are currently visiting multiplication, well, you can easily create this particular multiplication objects accordingly. So you would say returned new multiplication over here, and then you will simply pass the left and pass the right, and that's it. And now, how do we implement this particular visit addition? You'll be very, very similar. Okay. So what we can do is I can simply copy these 3 lines over here, except that I'm going to say new addition. So the logic and illustration will be just the same. So I will leave you for that. Okay. So now let's see if there's anything left. So now we got these 2 auxiliary attributes that we have to accumulate semantic errors, and this one is for us to check semantic errors. So this one is to accumulate semantic errors, if any. And we have done visit decoration. We have done visit multiplication, visit addition, visit variable, and visit number. We have done every one of them. Okay, what's left is the program. But now, given what you have seen, hopefully you can imagine how we can achieve for visiting the program. So let me switch to the AntlrToProg, another visitor. And there's only one method we want to override, which is to return program. So you can think about, so this is program context, right? So now you can think about we are trying to visit basically the root of the parse tree. And of course, this will be the very first visit method that will be called. Remember, the way we call the visit method is top down. Okay. So let me change my highlighter color over here. What about just okay, let me see here. How about just how about red? So this is the program node I want to visit, and now over here for the program, I know that I can potentially got more than 1 children over here, right? Well, of course, EOF also, don't forget that EOF, we gotta also treat them specially, right? It's basically, EOF is always the last child, you basically don't want to return any expression out of the EOF node. So now I'm going to retrieve maybe the first child, I'm going to retrieve the second child, I'm going to retrieve the third child and convert each one of them into expression by using the visit expression method, right? That's basically what we're going to do. And then after that, accordingly, I'm going to create this particular program objects and then add in, different expression objects into it. That's basically what I'm going to do. Okay, hopefully you're now a little bit more comfortable with this particular diagram here. This really goes closely with how we implement the visit method. So now let me just switch back to the visit program method. Before I try to encode this particular visit program method, I realized there's something fundamental I forgot. For voice safety, maybe you realize that too. You can see in this particular class we just finished programming, did I ever initialize these two variables over here? Maybe I haven't, right? So now if I simply create an object of type AntlrToExpression, these two variables might just be null. In that case, where do I initialize them, right? So that's a very important issue. You don't want to get into null pointer exception. So what I will do now is I'm going to switch back to this particular class and then define its constructor. Let's do that very quickly. And the constructor, of course, is very conceivable. You will simply say public AntlrToExpression. Okay, it takes no parameters. In this case, I would suggest we take one parameter for now. There's a reason for this. You can imagine that some other class is when they, you can think about AntlrToExpression class visitor is going to be used in the context of another visitor, namely AntlrToProg. And that class over there is going to pass the semantic errors list over here. It's just my particular design. Just try to see if you can understand it. I'll just put it here. Over here, string semantic errors. Okay, so now what I will do is, what about vars? For vars, I'll simply initialize that to be empty. New array list, and I can ignore this particular part. It can be inferred by the compiler. And then I'll say this dot semantic errors is assigned to semantic errors. Okay, so that's done for the initialization. And of course, I only need one public. Let me go back to AntlrToProg. So now you will see exactly how I'm going to use that semantic errors list. And for this particular AntlrToProg class, you can think about this will be the class that we're going to refer to when we actually do the main program, the application program, which will be the topic for next tutorial video. But for now, let's finish the current one by finishing the implementation for the second visitor class. So for now, for this particular method, the idea would be, number one, we want to also have a semantic errors list over here. So I'll say public, and this is going to be accessed by the application class. So that should be public. Again, may not be the best design. You can definitely feel free to improve it. Okay. My intention is just to get you some clear idea. Semantic errors. Okay, you can think about to be accessed by the main application program. Okay, again, I need to import it, so you can say control space, and then you will say Java util. Okay, so it's now properly imported. So now, how do we implement this particular visit program? The idea would be, we don't necessarily know in general how many children there are in this under this particular program context, right? So now, first of all, it should be a program context that we are talking about for this particular internal, the root. Let me write it down just as for completeness. So now for this program over here, this is program context. Program context of this type. And eventually we want to turn this node into an object of type program over here, right? Which is much easier to manipulate with. How do we do that? The idea would be this certain method for us to retrieve the children or the child nodes or the subtrees from this particular program context. This will be child at index 0, child at index 1, child at index 2, and all the way to the last child, which is EOF. Of course, this will be a very general, so we need a for loop. And for every child node that we are having, we should really recursively visit visited, which will be an expression. So we are going to call the visit methods from the AntlrToExpr class. That's kind of the idea. And then for each one of them, so when we let me just be more precise over here. So after, let me just not to be confused to you, confuse you about the color. After recursively visit this particular subtree, is going to give us one expression. After recursively visit this particular second subtree, that's also going to give me an expression. After visiting this particular one, the third one, which is rooted at here, that's also going to give me an expression. We're going to add in the expression into the program. Remember the program class from the previous development, the program class has only one attribute, which will be list of expressions. We're going to add it in one by one. We need a loop. Okay, let's say this. I would say program, first of all, okay, make sure I import it from the expression package. Program prog is new program. Initially, the list of expression will just be empty. Eventually, we want to return this particular program, eventually. But now we need to add in expressions that correspond to the subtrees of this particular program context, right? Over here. How do we do that? Well, I would suggest the following. First of all, we'd say semantic errors would be over here, just initialize it over here, and then we'll pass that to the expression visitor so they can keep accumulating it. So now new array list. Okay, ignore the list. Again, it can be inferred by the compiler. And then we are going to use a helper visitor. Okay, so that's also something you learned from the previous software design course. You can feel free to use one visitor in the context of another visitor. So AntlrToExpr expression visitor. I'm gonna write some comments for you. Is new AntlrToExpr AntlrToExpr. So now you see why I actually put this particular parameter over here for the constructor. Is because, so now for every iteration of the loop I'm going to run, you're going to accumulate the same list for all the errors. Okay, there might be some error, for example, potentially there might be error in this particular subtree. It should be accumulated when we visit this particular subtree, right? So you want to accumulate errors from all the subtrees. So now here, after this, I can now do a for loop. And unfortunately, you cannot really get the all the children directly. Oh, apparently I got some syntax error over here. Okay, let me fix it. Okay, and also let me put a semicolon here and say a helper visitor for transforming. Okay, let me just put it here. Each subtree into an expression objects. Okay, hopefully that makes sense to you. And the only way we can do it, okay, is to say integer I is assigned to 0 and then I less than. So CTX is a programming context. We can say get a number of children over here, get child count, and just use a for loop. Okay, and now we can go by index over there. And now we want to have a special case over here because remember what I said before. The last child for the top level start symbol is very special. Okay, let me just highlight it quickly. Okay, this is the start symbol, and the last child node for the start symbol should always be EOF. Otherwise, you will have some trouble for error checking. Okay, as I mentioned before, when we develop the grammar specification, we want to make sure this particular EOF will not be visited by the expression visitor. Otherwise, you might just return null, right? So what I would do is I would say do some distinction over here. If I is the last child, ctx dot get child count -1. In that case, I'll write a comment for you over here. Last child of the star symbol is Prog. Well, actually, Prog is the star symbol is EOF. Okay, so now we don't do anything about it. And then we say do not visit this child and attempt to convert it to an expression object. Okay, we do not. And every other child that's before EOF to its left will be okay. So now how do we do it? Quite easy. So we can say program dot, if you look at the program class, you have something called AntlrExpression. And then we can say, now for every ctx dot get child. And then I say I. This will not compile because this particular guy over here is of type parse tree. You can see it's parse tree over here. We simply cannot pass a parse tree where we are expecting expression. How do we do it? We have to recursively visit every one of them, every one of the subtree. So what I will do is I can say expression visitor dot visit. If you are not too sure about which one you may which visit method, visit declaration, visit variable, visit number, you do not just use the general visit. And this one is already defined in the ancestor class from the Antler library. Okay, the visit, you can imagine that it's gonna further delegates to the right to the appropriate visit method in the expression visitor class. Okay, so that'll be it. Hopefully, so far we haven't really got any test cases yet. I just want to go over all the implementation with you, and you can also at the same time take some notes and know about things like a get child count and also get text, get symbol, etc. Something you can write when you want to do the parsing, okay, to convert your parse tree into the expression objects or any model class you have. Okay, so now for this current tutorial video, the only well, not really the only, we achieved quite a lot. So we basically finished implementing the two visitor classes, and this diagram, even though become quite sophisticated, is really important for you to understand how we convert from parse tree over here into expression objects over here. And then remember, this is the inheritance hierarchy we're trying to follow. You will given any particular grammar for Antler, you will always have, if you chose the dash visitor option, you always got these two classes, and the range of the visit method you will get depends on the labels that you put on your grammar file, right? Remember the label that we put over here, and for example, the hash multiplication. And then also to understand how many visitor classes you have to implement really depends on your need. The reason that I needed two visitor classes is because one, if you remember this particular design for my model classes, you can see every class except for program, they are descending classes of expression. So they're kind of related by the same inheritance hierarchy. So they should belong to the return type of one visitor class, which is AntlrToExpr. On the other hand, program over here is not part of this particular inheritance hierarchy. So that's why I need to create another visitor class where the generic parameter t is instantiated differently by program. That's why. Remember this particular implementation decision I made is really, you may have to do something similar for your future developments.